Welcome back to Maths with Mrs. J. We're now ready to start talking about definite integrals. Now, here's a little bit of long-winded description of what is known as the fundamental theorem of calculus. I'll explain it in everyday English in a minute. This is what it says. If capital F of x is continuous and its derivative little f of x is piecewise continuous on an interval containing a to b, then the definite integral from a to b of f of x dx is capital F of b minus capital F of a. Now let me just translate that into everyday English. So we're saying, obviously we've got some conditions here. These functions have to be continuous to a certain extent. And we're saying that capital F is the integral of little f, because we're saying that little f is the derivative of that. So capital F of x, the derivative of that is little f of x. So the integral of f of x is going to be capital F, all right? That's why we're doing this here. So if you want to know the definite integral from a to b, what you need to do is find the integral and sub in b and sub in a and subtract them. Now, it should be pretty obvious that if you swap these ends, you're going to get negative, okay? Because we know that f of b minus f of a is negative f of a minus f of b. So, I mean, that's pretty obvious. If you're substituting them in round the other way, you're going to get the subtraction round the other way, so it will be negative. How do you set it out? Well, the good news is that we don't need to worry about our constant term anymore, because our constant term will, in essence, cancel out. If we have a plus c when we sub in b and a plus c when we sub in a, the c's go. How do you set it out? Well, what you do is this. You do it like this. 1 over x, the integral is natural log of x. And we write these numbers here like this. And all we have to do now is sub in natural log 5 minus natural log 3. And using our log laws, we can say that's natural log of 5 over 3. And that's perfectly fine to leave it like that. You can get an approximation, but we're not really into approximations very much unless it is actually a real life situation, in which case, of course, an approximation is very appropriate. Let's have a look at this one. Okay, what's the integral of cos? The integral of cos is sine. We're writing our values here. So we're going to get sine of pi on 2 minus sine of 0. Sine of pi on 2 is 1, sine of 0 is 0, so that's just 1. All of this stuff, our log laws, our unit circle stuff, is all starting to come in and tie together, which I think is a good thing. Some people think it's not so much a good thing, but that's why you learn all these things earlier on. All right, this is a composite function, but it's a linear function. And in fact, the linear function in this case, the derivative of it is just 1. So we're all good just to do 2 times x plus 4 to the 5th divided by 5 for our integral there. And we want to go from 3, well, from 0 to 3. So we're going to sub in 3. So we're going to get 2 times 3 plus 4 is 7 to the 5 over 5 minus 2 times 4 to the 5 on 5. You can work out roughly what that is. Yeah, I'd probably just be inclined to take out 2/5 and do 7 to the 5th minus 4 to the 5th. You can work out the actual number if you like. This one here, when we integrate, we're going to get a quarter e to the 4x, chain rule in reverse. So we're going to get a quarter times e to the 8 minus a quarter times e to the 0. E to the 0 is 1. So you can write that maybe as a quarter e to the 8 minus 1, or just a quarter e to the 8 minus a quarter. Either way is perfectly fine. Okay, this next one is the same sort of thing, but in this case we're trying to solve for k. Integral of 2 over x will be 2 natural log of x. And we know that this is going to be 2 natural log of k minus 2 natural log of 1. We should know by now that natural log of 1 will be 0. So this is the same as this expression here, which is natural log of k squared. And that equals natural log of 9. So k squared is 9. That tells you that k is positive or negative 3. We need to think about what's appropriate here. K can't be negative 3 because you can't sub in negative 3 into natural log. Remember, for this theorem to work, we have to have certain conditions met. And so k is negative 3 is not feasible here. So k equals 3. Just thinking for a minute also about that function, y equals 2 over x, you're going to have asymptotes at the axes. So if we're trying to go from 1 to k, and k is negative 3, that's not really going to make sense, is it? This is sort of getting us ready for our next video, which is going to be area under a curve.